Okay, so last question. A radioactive substance X decays exponentially over time. The quantity Q in grams of a sample of radioactive material remaining after T years is given by the formula. So T is years, and this is grams. So how much radioactive material is left in grams? You're then given a table of values. Find the value of A. So if we look at the first part of the table, we can replace Q of T with 240. We don't know what A is, obviously. E to the power of minus B, and T is 0. So what I've basically done is I've put these values into the function. Now, when I do that, anything to the power of 0 is 1. So this becomes e to the power of, e to the power of 0, sorry, which is 1. So that means A is 240. That was worth 5 marks in the test. It then says show that B is 0.1315. So I'm basically going to do exactly the same thing, only I'm just going to move to the next one. So in the place of Q of T, I'm going to put 210.43 equals. I now know A is 240. E is just E minus, I don't know B. In a moment, hopefully I can prove it, but right now I'm just putting it as B, and T in this case is 1. So what I'm hoping is that I can figure out this to end up to become that. So that's 210.43 is equal to, now that becomes 240 e to the power of minus b, because obviously 1 doesn't have any effect on the b. So now we just have to, I suppose, get this the way we want it in terms of our finding out our value of b. So I think it would be a good idea to put our e to the power of b underneath to get rid of the negative. Now, if I cross multiply, I get 210.43 e to the b is equal to 240. And then to get e to the power of b on its own, I'm going to do 240 divided by 210.43. I'm just putting this into the calculator. Now, so to get rid of this, I'm going to have to get the natural log of both sides. If I get the natural log of both sides, remember natural log is log to the base e. So if I bring my b down to the front, the natural log of e is, as I said, another way of saying log of e to the base e, which makes that a 1. So now if I get the natural log of whatever is remaining, that should give me the answer that I'm asked for. So the answer I'm getting is 0.1314, etc. So to 4 decimal places, it is 0.1315 as requested. Finally, find the time in years, so basically find T, that it takes for a sample of radioactive material to reduce than less than 5 grams. So writing out the formula, 240 e to the power of, now we know B is negative 0.1315 T, and we want this to be less than 5. So again, I think I will move the E underneath to make it positive. 0.1315 T has to be less than 5, and I'm going to put that over 1. Now I'm going to cross multiply. The reason I'm okay to cross multiply is because T has to be positive. There's no such thing as negative time. So I'm okay in that sense to cross multiply. Now, so what I'm going to do now is move the 5. So I think I'll just move the 5 over just to tidy this up as much as I can. So that's going to be 240 divided by 5. So that's 48. 1315T. Okay, so what else can I do? So I suppose I can move my power to the front. So in other words, if I get the natural log of both sides, I can put that power to the front. So I can do 0.1315t natural log of e. Now remember, natural log of e is just 1 because natural log of e is really the log of e to the base e. Any matching log and base is 1. So that becomes 1. So we're nearly there now. So t should be natural log of 48 over 0.1315. So putting that into my calculator, natural log of 48 and over 0.1315. So that's giving me 29.4387, etc. So the time would have to be over 29.44 years to 2 decimal places.